All right. So we're starting to get into some algebraic concepts, and we're going to start dealing with linear graphing lines. And I know some of you have already graphed. So you have a linear equation is a straight line. What are some things you know about straight lines? Yep. They're straight. Good. All right. Building on beyond straight, what else can you tell me? Do straight lines cross the x-axis? That's this.
Yes, sir.
They will? What about the y-axis?
Yes, sir.
And does anyone know what the pitch of a line is called?
No.
We use it as m.
Mx plus b.
So what does m stand for? Alright, so we have slope of a line, that's the pitch of the line, that's the rise over the run, the direction that goes in the y direction or the up and down direction over the direction it goes in the x direction, which is the right or left.
What?
I said direction like 20 times.
Slope rise
You're gonna
over run. No, I think no. If you don't understand it, this is a concept you've only heard since 5th grade. So either you didn't pay attention through 5th grade, which I had looked back at some of your scores in middle school. I'm not quite sure why they let some of you out of middle school because some of you did absolutely nothing in middle school, and then you're sitting here in high school going, I don't get this. Well, why don't you get it? Because you haven't done anything for 3 years. So figure it out. All right. Rule. So we have kind of an input and something that takes place as an equation, and then an output. So what's happening is if we plug 130 in, we subtract 80 to get 50 out. If I plug 290 in, subtract 80 and get 210 out. So this rule is we're just subtracting 80 each time. So what do you think this should be if I'm getting 20 out? How much? Yeah, so oops. Wrong way, get in there, stop. So this one should be 100. What about this one? Go the other way. So if I go from here to here, I subtract 80. If I go from here to here, I add 80. So I added 80, add 80.
50.
Yep. And then add 80. What do you think that one gets to?
420.
Yep. Sweet. Okay, so this would cause it to be a linear function. So each time we plug in some sort of value, we subtract, in this case, 80 out. Or if we work backwards from it. So this is something you've probably seen before. All right, so in a relation, these are just points, ordered pairs, lists of numbers. That's all relations are. So it just means that we have two different number lines where one's an x-axis and one's a y-axis. All the x-y axis is using fancy terms. You can call it as the Cartesian plane, the coordinate plane, the xy axis. It all means the same thing. It's two number lines that are put together perpendicular, and they allow you to find a location of something. Okay? A function's a special type of relation. That the x values don't repeat. And honestly, when you're looking at a bunch of ordered pairs, a bunch of points, 3, 5, 10, 6, things like that, you can see real quick if the x value ever repeats, then we still have a relation, but it's not a special kind of relation called a function. this seem okay so far? So far we're just talking about, if I had points plotted, that's a relation. If I connected those points, it could still be a relation. But if our x values don't repeat, we have ourselves something called a function. And a very simple function test, if you're looking at a graph, is called the vertical line test. If you can draw a vertical line that touches your graph one time and only one time and no more than one time, that means you have a function. If you had something like a circle, if I drew a vertical line through a circle, it can definitely touch it twice. Make sense? So again, we're talking about special types of relationships called functions. Relationships are ordered pairs. They could be ordered pairs that are connected to make a graph. They could just stay as an ordered pair. And then special types of relations are called functions, in which our x value doesn't repeat itself. Didn't say the y couldn't, so excuse me, may I move on? Excuse me. Can I move on? All right, so now, domain. X value. Input. These are all names for the domain. This is just, if I have a list of numbers or a list of points, let's say I had 3, 5, and 2, 8, my domain would be the x values. So what are my x values of those points? 3 and what? 2? Okay, so this case we only have 2 numbers. The range can be called the y values, and also could be the output. So what's the range of our above? That's supposed to be an 8. What's my range if they are the y values? 5 and 8. Okay, so just remember your ordered pairs. They are in alphabetical terminology. X comes before y. It's x comma y. Get it? Did it spill on you? Good deal. I understand. Big water bottle. Can I move on? You've heard some of this stuff before? I hope. If not, we got some major teaching that's got to take place. All right. So we want to know, is it a function or is it not a function? So this would yield me the point 2, 4, 4, 8, 10, 20. Do any of my x values repeat here? I have 2, 4, 4, 8, 10, 20. Is there any repeat of the x value? Yeah.
No. Oh. Of the x? Can it be in y?
Looking for the x only.
Oh.
Doesn't repeat? Function. Okay? And again, I could make these ordered pairs. This could be 2, 4, could be 4, 8, it could be 10, 20. Okay? It's just one way they have it mapped, one way you can put it as ordered pairs. What about this second problem? I have 1, 20, 1, 8, 4, 4. Is there a repeat of the x values?
Yes.
So it's not a function. Now it's still a relation. Again, a relation is just ordered pairs. But if I have 1, 4 and 1, 8, and then 4, 20, it doesn't matter that the 4 repeats as an x and a y value. It's that's repeating is our. That means it's not a function. If I had drawn those points 1, 4, 1, 8. It doesn't pass the vertical line test because a vertical line would go through 1, 4 and it would also go through 1, 8. What about this third one? I have 1, 10, 2, 10, 3, 10, 4, 10, 5, 10.
Yes.
Function. Total function, even though it repeats the range, the y value nonstop, it's what's taking place. And then what about this fourth one?
Not a function.
Why is that?
There's 2 ones.
That and that gives you not function. Again, if you had graphed this on the xy axis, the Cartesian plane, the coordinate plane, whatever you want to call it, Vertical line test wouldn't pass on this one. Now, I gotta tell you, this right now, what you're hitting here, we're focusing on and building a lot more in Algebra 2. At this current time, it's not like, so when you're like, okay, am I gonna see this again? This will be built upon in Algebra 2, so next year you take geometry, the following year you take Algebra 2. Why do we split the two? Because, I don't know. Someone at the top made a decision. It's the right decision? I don't know. I've taught it all kinds of ways. I've had Algebra 1 and Algebra 2 one year after the next, with geometry as the third year. I've taught it this way. It all seems to get us to the same location. All right, vertical line test. Pretty simple and easy. Can I draw a vertical line that touches this graph only once? Nope. So is it a function? Not a function. Didn't pass the vertical line test. Vertical line test on a circle. Function or not? Nope. Not a function. Still a relation, but not a function. This is called an absolute value function. So vertical line test, I could make all these vertical lines all day long and only will touch my graph once. So is it a function? Yes, function. Make sense? And a lot of times in certain types of computer programs, they have certain things that are testing for a function. Nowadays, are any of you starting to become password illiterate?
What does that mean?
Like, you can't remember every password?
I do the same password for everything.
Yes.
Well, I tried to. But then, like when I teach at Arapahoe Community College, my password has to be 105 characters in length.
Arapahoe Community College.
Are you serious?
105. So they say write a paragraph that you would only know. I'm like, I don't know if I know 100 characters. So I was like, when I was a young boy, I was born in New Jersey. My mom's name is Jane. My dad's name is Robert. I mean, and then you had to add capitalized in there. I mean, I'm looking at them going, dude, this is a community college. What part of this means 100 characters?
You gotta write the lyrics to like your favorite song that you know.
I bet that'd be good. But still, it's a community
Or you could
college.
write the alphabet like 4 times.
Yeah, good for you. 26 times 4, love it. You can't do one lowercase, one uppercase. I just thought it's ridiculous how I have to log into them because I'm like, okay, the United States government doesn't have anything this restricted. A whole bunch of them.
Yeah, just period.
3.
Period.
You could write like
4 times and then do an exclamation point.
Wait, did they
See,
seriously-
that's why you guys aren't illiterate as far as passwords.
This is why they need us in the future.
You got that right. You all figure this stuff out. With me, it's like, okay, this needs to be 4 characters in length. Make sure one's capital and one's a special symbol. Okay. Next one. This has to be your fingerprint. Oh, good. Which finger? Doesn't matter, sir. Just put one finger here. Oh. So now it's this finger. What if I lose that finger? Then we'll have to reset the system, sir. Okay. I'm 47. I should keep my finger. Watch, I'll come in tomorrow missing a appendage. You're like, what happened? I lost a finger. Someone stole my password. All right, is y equals 2x plus 3 a function? Why or why not? And it says hint, think about the graph. Okay, hang on. I want to try and graph this. I want to see if I can do this. XY axis, yes. And let's do it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7.
2 up, 3 across.
What do you mean 2 up, 3 across? Does anyone know what this would be? What value that gives me? Not my mom, no.
Wait, what? Wait, which one is which again?
So this one right here, the value that doesn't have an x attached to it is the y-intercept. So that's good to find as 0, 3, which would be right here. Is that okay? How do I find a second value if from this? This is my slope. So my slope is going to be 2 over 1. So what do I do when I graph and I know a slope? Anyone remember?
Plot it.
Plot it how?
Uh,
The slope is a map to find a second point. So I have one point right here.
find your y, yeah.
So I'm going to go up 2. It's rise over run. And this might be newer stuff, but this is what this graph would look like. It's going to keep going forever both ways. So I could label it, this is functional notation. Is that black line I just drew, does it satisfy a function? Vertical line test works?
Yeah.
I can take a whole bunch of vertical lines, draw it, we'll touch it only one time, right? So I have a function. This is called functional notation. So it's right there, I don't have to write it. Okay? It's a fancy way of saying why. But then they say, hey, we want to know what the function at 6 is. Well, if my original function is 2x plus 3, if I want to find the function at 6, I'm going to replace the x with 6. Now I'll do my math operation. 2 times 6 is 12. 12 plus 3 is 15. So this would yield me a point, 6 comma 15, if I wanted to plot it. But my answer that I'm truly looking for on this one is just 15. All right. What about this one? Anyone want to take a shot at what that means? What does this mean? F at x equals 6. Well, here I have f at x equals 2x plus 3. That's dotted, but it is. 2x plus 3. And then we know f at x equals 6. So what do you think I should do with that 6? Equals 6. There you go. How can I solve this equation? Subtract 3 from both sides. Good. And then divide by 2. So that's going to give me x equals 3 over 2. And again, that would then yield me the point 3 over 2, which is 1.5 comma 6. Okay. And we're going to be working with a lot with these. So it's not one and done and we're good. We're moving on. Good to move forward? Yay? All right. So f at 1. Do I plug it into the first or the second equation? What sticks out and tell you? Why is it the first? Because of the f. Good. So f at 1, f at x. So I'm going to go negative 3 minus 2. That had been an x. I'm going to plug a 1 in there. So I wind up with negative 5. What about this one? Which equation does that go in for, the first or the second? Second one, because it's g, so that's going to be 10 parentheses plus 2. That had been an x. What's going there? 1. 10 times 1 is 10. 10 plus 2 is 12. Which equation, first or second? Okay, because it's f, right? So negative 3 times x, but I'm going to put a 0 in there now. So I get 0 minus 2, so I can just get negative 2. What about this one, first or second? Second. Okay, so I have 10 times, 10 times blank, 10 times x, so this is going to be 10 times 0. That's 0. 0 plus 2 is 2. What about this one? Which one? First one, so I get negative 3. It had been x there. What am I plugging in for x now? Negative 1. So negative 3 times negative 1 is positive 3. 3 minus 2 is 1. about this one? Second one. So that's 10. It had been 10 times x, but now it's going to be 10 times negative 1. So negative 10 plus 2, which is negative 8. Now we get to a little different rock and roll. What do you think I should do here? And why? There you go. So you're going to have 3x minus 2 is equal to negative 8. They want to know what the function of x is, and that happens to be equal to negative 8. We're going to go ahead and solve this. So I'm going to add 2 to both sides. Divide both sides by 3, negative 3. So I wind up with x equals 2. So on this one, I'm not just getting a value, I'm getting an x equals value because I got to solve it in the equation. What about on this one? What should I do? So I get 10x plus 2 is equal to 32. Subtract 2 from both sides. Divide by 3. Divide by 10 to get 3. Okay, so sometimes you're plugging in for the x, sometimes you are setting the equation equal and solving for the x. Make sense? Everyone happy? How many more notes do we got?
Oh, one more slide.
One more slide? Really? Dude, I could totally do this. Alright. Ooh. So let's see. Heart rate, time in minutes, and then beats per minute. It looks like their heart rate is increasing. So they might be exercising, or there might be some activity they're doing. So the domain, so let's think about our x values. All the way over here, this is 0, right? All the way over here is 60. So my domain goes from 0 to 60. Is that okay? Let's take this a little further. What does my range do? What's my lowest value I'm going in the vertical direction? 70? Awesome. What's the highest I go to? Is it right here? 160? Is that okay? So notice I didn't look to the total endpoint. I looked at whatever the highest and lowest values were. The interval where it's increasing. All right, I think we can do that. Let's see. I'll use our highlighter. All of those yellow regions where it's pitching towards up is where it's increasing. This is where it's decreasing. So increasing means it would have a positive slope. Decreasing means it would have a negative slope. So what's the interval where it's increasing? Well, we're going to list it. We're going to go from 0 to 15. So from 0 to 15, we're increasing. From 20 to 30, we're increasing. And then from 35 to 50, we're also increasing. Those are not points, those are just the values in the x direction where we are showing the graph is increasing. Where is it decreasing? It's all of the blues. So it looks like 15 to 20. It's also decreasing from 30 to 35. And then it's also decreasing from 50 to 60. So that just means the slopes at those regions would be negative. The slopes of the increasing would be positive. What is my maximum value of my function? What is my highest y value I get to up there? Highest y value. 160. Awesome. And let's see, last one. What is my minimum value? What is my lowest x value up there? What's my lowest what's my lowest y value up there? 70? Cool. So we did that problem. Let's see if we can go a little faster on this one. Okay, so we want the domain. It's going from 0 to 12. I guess we can make square brackets. The range, what's all the way down here? 0, and it's going all the way up to 24. That okay? When is it increasing? It's increasing right there. That's the only place it's increasing. So from 6 to 8, it's increasing. When is it decreasing? A lot. From here to here, here to here, and here to here. Okay, so it's decreasing from 24 to 6. And it's still decreasing from 8 to 12. Though it changes, you could say, because it doesn't change between increasing and decreasing on this final region from here to here and here to here. Let me get that. And all right. What's the maximum value of our function? What's the highest y value we have on it? 24. Oops. 24. And what's my minimum? Looks like 0. Everyone okay with that? Okay, so your homework, hang on, don't get up, sit. You got some time. You'll be all right. Thank you. Thank you. Perfect. Here, find it first. Okay, so I saw in our notebook, so this is going to be goofy because our notebook got goofed up by print services. So I would like you to do page 47 and 48. Okay? They're two opposite pages from each other. Okay? So whatever we did wrong, the photocopy people didn't do right for us. So when I mark it off tomorrow, you just can have your notebook open, and I would actually just collect one of the pages, though I'm looking to see both of them are done, because that means the next day is goofed up as well. And I don't think we're going to be able to make it better on this unit until we have a 3-page thing. And oh boy, they really screwed it up. They goofed it all up. I'm sorry. Oh wait. Yeah, we'll make it work. So, but page 47, 48 is what you need to work on for next time, if that's okay. Can someone grab my phone? And someone grab your phones?